Hi, I'm David Stark. I'm the developer of Airships Conquer the Skies, which is a game about building airships and fighting with them. Today I want to talk to you about some AI work I've been doing. So recently I just introduced a new thing into the game, which is ramming prows, which allows you to effectively ram other airships to blow them up. This of course means that the AI also has to be able to understand how to use them. So I ended up going back over the AI and I thought I'd just show you kind of how it works. So here's an example combat. Set it up with an enemy ship that uses grenades, which means it has to get really close to a mine, which will encourage it to do some interesting maneuvering. And here's my ship. Okay, and then we start, and as you can see, the ship with the grenades maneuvers around the floating rocks that are in the way and eventually finds its way into a position where it can throw grenades at my ship, but my ship can't actually do anything to it because the cannons don't go up that far. So let's move back a bit. So it's in firing range again, and as you can see, the other ship adjusts and moves again to make sure that it can't be hit. So how does this work? Basically, each airship keeps track of all the various locations in the fight and thinks about which location is the most advantageous in terms of being able to inflict damage and being protected from damage. So, and if it can't find a good location from that point of view, what it does is then instead finds one where it can maneuver better. So what you can see here is that this airship can't really find a place to shoot from right now, but it can go to a place where it can maneuver better, which is, you can see here this little highlight bit here. So the red dots represent locations which are very bad for the ship to go to, or it can't even go there at all. The black dots represent locations which aren't very good, and then the light grey or white dots represent locations that are optimal for the ship to position itself. So in this case, this is this vertical column here, where the ship will be able to shoot at the enemy without being hit itself, because it's behind the enemy. So it will move, and now it's in the optimal position. So moving and shooting aren't really talking to each other directly. The moving system simply figures out where it has to be to shoot. Here you can see it from a bit closer up. As you can see, the bit that's best is really just when we're straight above the enemy ship, but behind it. That works very effectively, as you can tell. Okay, so now ramming. So here we have another pair of ships, and the one on the right, the enemy, is equipped with a big ramming prow. And so we're gonna see how it actually does the ramming. First it gets into position, and then when it's in the right position it accelerates at maximum speed moving forward, and you can see the result. Once it's done that, it moves right back and starts on the next run. But just keep on ramming the enemy ship, inflicting damage until it's victorious, obviously shooting at the same time as well. So the ramming behavior overrides the normal movement behavior, and the normal movement behavior will still happen even it will still happen if you can't ram properly. As you can see, it's done pretty well. So how does that work? Well, it's based on the same set of numerical values, but this time it also looks at, well, where would be an optimal position to ram from. So you can see here that it really wants to be in this particular area, because in this particular area it's at the same vertical height as the enemy ship, at a good distance away to accelerate for ramming. So it goes there, and then it moves forwards to do damage. And once it's done that, again the system goes out of ramming mode, the system takes back over, it goes back to where it needs to be to do another ram. This is really quite nice. I can put any kind of behavior I want, at least if it's about movement, into this kind of field of values. So in future there's also going to be behaviors like boarding other ships, which will require other specific movement behaviors, and I'll be able to just include that in that matrix of values that encodes where the ship needs to be. And if I need to look over this stuff, I can just use the visualization which I showed you to debug what's actually going on. Yeah, anyway, I hope you enjoyed this short insight into how the AI works. If you want to try out the game, you can. It's available right now. The link will be in the description. It's also on Steam Greenlight right now, so you know, please upvote it. It's by no means done, but as you can see, there's a lot going on in development. And yeah, thank you for listening.